Ironically, it was gravity that was the first force to be more or less described mathematically by Isaac Newton back in the 1600s. But there was a problem with Newton's equations. When you write down Newton's equations, you realize that gravity spreads infinitely fast throughout the universe. So if the sun were to disappear right now, if the sun were to disappear, it would affect the Earth immediately. We would be hurled into outer space instantly. Well, there's a defect there, and the defect is that there's no mention of the speed of light. We see no deviation from Einstein's theory in the laboratory, and Einstein says nothing can go faster than the speed of light. Even gravity cannot go faster than the speed of light. So Einstein had to introduce a new picture. He replaced this idea of an instantaneous force that could spread instantly throughout the universe, and we replaced it with a fabric, so that if the sun were to disappear right now, the ripples of that titanic disappearance would then permeate around the universe, just like waves on a pond emanate from the place where the stone first hits the pond. Well, now we have the quantum theory, and the quantum theory says, no, this can't be right, because forces are carried by particles. And so we have to take Einstein's theory and bust it up into little particles called gravitons. Unfortunately, gravitons have never been seen in nature. We know they must exist. And gravitons create waves. Now, we've seen those waves. These waves are called gravity waves, and they were seen just a few months ago, making headlines around the world. But these gravitons, that is the origin of these waves, little particles of gravity, have not yet been seen in the laboratory. And it may take many decades before we have instruments sensitive enough to pick up gravity waves. Now, why is that important? Because that would give us a unified field theory of everything. So the short answer to your question is we don't really know. However, the leading theory is that these gravitons are actually tiny little vibrating strings. So think of a rubber band. A rubber band vibrates, creates all the particles of the known universe, but from a distance, the rubber band looks like a dot. That is a graviton. And that's how we introduce the quantum theory into Einstein's theory, by introducing little loops of gravity, little strings like rubber bands. Enterprise. So first of all, what are your thoughts about starships? Is that really just science fiction, or is there any physical basis to going to the stars?
Well, I think, the only way it can happen is